Hello everyone, another random product review. This one is a result of me starting to play airsoft. And I live in the tropics, so it's hot as it is, but when you start running around with a bunch of heavy military clothing on, you get really hot, like close to heat stroke in an indoor arena with no air conditioning. So I had this freebie, so I think I got this free or it was a really cheap stainless steel mug, but it's not insulated. So it's just, I pour some water halfway and then it expanded. Obviously, you don't want to ever fill anything up fully and then freeze it because water expands when it freezes. It would blow this thing up. Anyways, this thing melted very quickly the last time I used it. Probably within 2 hours, all this ice would have been gone, right? Because it's not insulated. You can even see it condensing here. So today I went and got this thing locally. This is a Japanese brand. Zojirushi. All right, so it's a 2 liter, a little over 2 liters, and I checked it out at the store, department store, and the reason why I bought this one is the ability to clean it. So let's take a look here. It's all Japanese, but this one's insulated, and then some sort of easy going cap there. Can't read any of that. Here's the part number if you want to search this out online. SD-BD20-BG. It came with a blue colorway, or this one is neonish green. I figured it'd be easier to find if I ever left it outside at like a airsoft field in the woods or something. So we got some plastic there, and actually in this bag I think we have something. No, some warranty card and how to use it, but this can't be that much to it, right? It's a water bottle. Well, apparently you can disassemble it for easier cleaning. How to attach the stopper gasket. Okay, let's see if I can figure this out without reading that. More foam. So first, assuming it would be full of liquid, you have this lock here. So that's keeping the top part down, then this pushed on the bottom. And so then you can drink right out of the spout here, and it's got a silicone seal, and let's see if I can remove it. Yes. So you can clean this seal out nice and easily, and this hard plastic is a little hollow in the pole there. So you have to have a fine brush to clean out any grime that gets in there. But I'm going to guess not much grime would get in there because it's sealed here, pretty far. But that's what's going on there. Pop that back on. Nothing else. This is just, some sort of nylon plastic. And the hinge here, it's just a hollow steel tube hinge. It's not a solid steel pivot. So you can actually see light through that hinge. Interesting. Well, hopefully it's durable. Only time will tell that. So this green plastic here seems relatively durable. And again, the hinge is hollow. This brand's been around for a long time. So several decades. I don't know when they first started, but my dad, I think, had this brand of thermos when I was a kid. And I'm not a young person myself, so okay, so let's see the bottom of the lid here. Let's close this up. So there's another silicone seal, and that's what's, I guess, sealing it to the bottom of the container. And this can be removed as well for cleaning, so that's good because grime usually does get in there. Bacteria will start to build up in there, so you want to clean that out with some I use a toothbrush to get the soap all in there and brush all the grime out. I gotta edit this in here because as I was cleaning it, it turns out this whole thing comes out easily. You just push the nozzle down. So you can clean this section obviously a lot easier if it comes out of this section. Although honestly, I'm not really sure why this would even need to be a separate piece in the first place. Right? I don't know why they couldn't just mold a piece of plastic to have this inside surface, because this looks pretty easy to clean on its own. But I'm sure, again, they know better than I do there is also a seal here. So this seal is against the vacuum container bottom. This seal is to seal this thing, and then this thing screws this whole thing down properly. Maybe it's less plastic. That might be the reason why they did that. Because if this spout was part of this would have to be an extremely rigid thing to be able to seal it, and, well, I don't know. Okay, let's get back. So the threads are pretty wide. It only took a few revolutions. Let's count. It's like less than one revolution to get that thing on. And it's a lot of friction because the silicone seal seems to engage immediately. So to take this off, maybe 1 1/4 turns to add or remove that thing. So that's very fast. This silly string thing, some features or whatever. Okay, so the next thing is this. This is a nice opening. Let me get a ruler. Alright, so some of the listings I was researching online don't actually tell you the diameter of this, but it's a key thing I'm looking for because I want to know I can get my hand inside of this to clean it easier. This diameter, inner diameter for this plastic lip I'm measuring now is about 76 millimeters, or about 3 inches. Alright, so I wear a size extra large motorcycle glove, and it's with a little effort, I can get a rag in there, you know, a cleaning sponge, and clean out any grime in that thing really easily. That I cannot do with this thing, so I have to put one of those giant brushes in there, and it's just a lot harder to clean something like that. Inside this thing is like a powder coated or something. I don't know. It's like it's a gray color. I'm sure it's stainless steel, but I think it's actually treated with something. Maybe to, well, I can't explain why they would do that. All right. So the threading seems to make the opening in the middle of this handle. It stopped there, can't go any further. So the handle itself seems quite robust. It's hollowed out in the middle here, but I'm trying to torque it here. It can flex a little bit, but I think durability of this handle won't be a problem. I mean, I guess if I smashed it on the ground on purpose, I might break that pivot. But for general use, I don't think it's going to ever be a concern. This is in the back position, and then it sits more flush in this position. Alright, this base here seems to be the same plastic as the top. It's kind of like nylon plastic. And this one seems a little tacky though. Then again, this seems kind of tacky as well. It might just be the molding texture of it. So plastic, then this is the steel, and then back to plastic. Okay, we're going to do a iced beverage cool down test. Basically, I'm going to fill it up with what looks like 4 cups or 1 liter of ice, and then the rest of it will be water. Granted, this ice is pretty big, so I think it's a realistic amount that I would actually use because I want to drink liquid more than ice. Right, but I want to keep that liquid cold. So let's fill this up. Okay, so that's roughly a liter of ice, but obviously less with all the air pockets, or 4 cups. So here's a liter of water. So we'll, after this one, so let me get the remainder. Alright, let's fill up the thing all the way. Right to the gray rim. Okay, so that was around, hard to tell on this thing. Around 2 cups or half a liter more. So basically there's only half a liter of ice that I put in there, and a lot of it already melted because that water wasn't very cold. It's just room temperature tap water. Well, a water filter tap water. So here's my laser thermometer. So right now it's 3 degrees Celsius, or 13, 9, 7. Anyways, it's cold, right? Let me change this over to Fahrenheit because it's a larger group of numbers. I gotta switch over here. So 36C. I mean, it's 37, 40 Fahrenheit. I'm gonna leave it at Fahrenheit because it's a larger number spread than Celsius. All right, so 30 at the, yeah, somewhere in the 30s. So now let's cap this off, and basically I'm just going to check it every half a day or something, and see how many days it actually takes for all that ice to melt, knowing that there's a half liter or less than half a liter of ice in there now. But that means that's a logical amount I would use because I want to drink the fluid, not the ice, right? So the majority of this is just cold water right now. So let's see how long it takes for all that ice to melt. Time to do a 12-hour check. Let's see how much ice is melted, or maybe, I'm sure a lot of it's still in there. Boy, this thing is really sealed. What do you know? All the ice is gone in 12 hours. And it's 47 degrees 56. Well, I'll be darned. Yeah, 47 Fahrenheit. So it's gone up quite a bit. Well, that's quite interesting. So 12 hours is really the amount of ice it's going to hold. Not even. Granted, it was only 1/4 ice, but still. Well, now we know the answer. Maybe I'll do another one. I'm going to empty this and refill it with more ice, and then we'll see how long it lasts. Alright, so this time I'm going to fill the entire thing with ice, or try to. Let's see if we have enough. Okay, so we have the whole thing pretty much filled to the brim with ice. I'm going to take that same 47 degree water, so it's actually pretty cool water, but why not? I guess we could compare that to like refrigerated water. Oh, let's see how much water fits in now if this is full of 2-liter large ice cubes. So I'll fill this to a liter. Great, there's a hair in there. So that's a liter of water. So that's interesting. I filled up the whole 2-liter thing with ice cubes, and I almost filled another liter of water into a 2-liter container. So filling up these particular shaped ice cubes is like a good 50% air, or even more. So there's just a little bit of water left. Let's see how much. There's 150 milliliters left. So I put in 850 milliliters of water. So naturally this is really cold. 35 Fahrenheit, 33, 35. Same as the first time, I guess. Okay, let's cap this off, and I guess I'll check it in 12 hours again, because now we have a lot more ice. Alright, so a 12-hour checkup here. Let's see how the ice is doing now. There's just a big blob of ice in there, as you can see. Oh, well, look at this. The temperature, though, is 45. It's rising, the water. Before it was always in the 30s. So, hold on here. Try to get an idea how deep this... Unfortunately, I can't break this. Well, still obviously plenty of ice. Well, it's time to check in after a complete day of sitting around indoors here. It's basically like 85 degrees Fahrenheit, typical indoor air-conditioned weather here. Let's see what kind of ice we have here after a day. So, yeah, there's still a big iceberg down there. Oh, I'm not sure if you can see, but if I shine the laser, like the top, maybe around that far, is all water, but there's still a giant chunk of ice inside this thing. And it doesn't look like it's melting much. Alright, 36 hours. Let's see what is happening. Boy, there's still ice in the same region. Alright, time to do a check after 2 full days. Yeah, there's still ice in there, but it's melting much lower. You know, it's still in there after 2 full days. Got some chopsticks here. Alright, so that's where it's touching down, where the ice is. So, looking at this thing, boy, the ice is half filling this thing, according to that. Alright, check after 2.5 days. Okay, well, there's still ice down here, but it's almost a full chopstick now, and at least in the middle. Alright, the last check, this is 58 hours, so more than 2 days, almost 2.5 days, and there's still ice in here. Oh, but it's just it's relatively small now. So I have to use this thing. I'm assuming actually it would take about 3 complete days to melt all this ice if this whole thing was filled and then with water. So hopefully that helps you guys out. It's a high quality item. Yeah, I'm pretty happy with it. It's much more than I expected. It's really strange that the first ice thing melted in 12 hours, but then this whole thing takes significantly more. Alright, well, thanks for watching. Bye.